JavaScript library for, well, you can read it up there, fast multidimensional filtering for coordinated views. That's the tagline, kind of, from the website. It is a library that will oftentimes be used to back data visualizations that are done in the browser. So I'm not going to be talking so much today about data visualization per se, how to do it with D3 and that kind of thing, but rather how to handle the data structures behind data visualizations. So that said, if you have any questions during the talk, please just speak up. Happy to answer them as we come to them. I'm not going to be doing any live coding demos or anything like that, but there's going to be a fair amount of code up on the slides. Can everybody in the back hear me okay? Great. All right, let's go ahead. So CrossFilter is a library, but I think importantly it's a library that we use in the context of building tools to help other people work with data, explore data, understand a data set. There are a lot of situations in which you won't want to use CrossFilter, which I think you'll see as we go through the presentation. It's really made for situations in which people are going to be interacting with the data that you have in the web browser. So if you're just going to be telling somebody something, showing them a report, doing a one-time aggregation, something like that, CrossFilter is probably not the tool you want to be using there. But if your user is going to be interacting with the data, filtering on visualizations, and seeing other visualizations update because of those filters, changing aggregations, adding and removing dimensions and groups, then CrossFilter might be something you'd want to look at. I think that a really key aspect of this tool idea that I think we need to keep in mind around data is kind of the concept of a sense of understanding where our body is, where a tool that we're using is. When we use a hand tool or something like that, we know where that tool is. It kind of becomes a little bit of a part of our body. There's some interesting psychological studies about that. That sense is called proprioception. And it's the idea of having a sense of where in space your body is. If I catch a ball, I'm not watching my hand to try to know where my hand needs to be to catch the ball. I'm watching the ball. I don't need to watch my hand to know where it is. If I'm using a tool with my hand, I don't need to necessarily look at that tool if I'm comfortable with it to know where that tool is. I can look at what I'm doing. If I'm trying to work with data, then I don't want to be looking at the tool that I'm using so much. I don't necessarily want to be very carefully trying to filter and looking at that. I want to be looking at the result of the operation that I'm doing. And a really important aspect of proprioception is kind of synchronous feedback. When I want my hand to move, it moves. I don't have to say, hey, move, and wait for it to move, right? But a lot of tools that we use to work with data, that's exactly what we're doing. We click on something to filter onto a dimension, and we wait for a second or a few seconds for that filter to take effect. And that ruins the use of a tool, basically. It makes it kind of not really there for us. It's something that we interact with instead of something we use. Okay? So a really key concept that CrossFilter was developed with was synchronous and basically instantaneous reaction to user input. So we're talking reaction to filtering on the order of 10 or 20 or 30 milliseconds, less than a tenth of a second, which is more or less where things become really perceptible to users. So I think that's the basic idea. Let me show you a couple examples of what I'm talking about that will, hopefully I can figure out how to get it up there. There we go. All right. So this is a little odd the way that it's set up. This is the tool that first got me interested in this. It's what Moritz Stefaner calls an elastic lists interface. It's a way of, in this case, Nobel Prize winners. It's a way of just quickly drilling down into data and finding a particular slice of data that you're interested in. So if I'm interested in Nobel Prize winners in physics, I just click on physics, and it filters down, and all the other categories update to show me within physics how they're distributed. So I want to see physics. I want to see people who won Nobel Prizes in physics from France in the 1960s, and there's just one person there. Really fast. those categories update basically instantaneously with some animation, of course. This is pretty old, developed in Flash. He put it together a long, long time ago. This is a tool that I helped build called Palladio. Kind of a similar idea. This is a data set that is focused on people who had some kind of interaction with Monaco. And you can see where they were born. That's the green dots. You can see where they died. That's the red dots. And you can see a timeline. You can see their lifespans on a timeline. So if we want to look at people who were alive during a particular period around, say, 1900, we can just highlight that area, and our map updates as we're doing that. If we want to see how things change over time on the map, we can just drag, and our data updates as we're doing that. This isn't very much data. It's about a couple hundred records right now, a couple hundred people. On the back end, we blow it out a little bit. It gets to be a couple thousand records. This is a few thousand records. This is a dc.js example. It's a library that is built on top of Crossfilter and D3. And it's investment data, stock market ups and downs over the course of 12, 15 years. So it's several thousand data points. And again, they're animations, but the updates are basically instantaneous. I click, I see what changed. I see that Tuesday wasn't a very good day in 1999. I wonder why that was. This is the Crossfilter kind of canonical example, if you go to the Crossfilter website. And this is over 200,000 records, flight records, from the first part of, I think, 1999. And we can ask interesting questions using this type of interface. Again, filtering on over 200,000 records in real time. So, for example, if we want to see where delays are distributed, where are the biggest delays during the day, we can very quickly just filter down to long arrival delays, and we can see that they tend to be distributed towards the end of the day. So maybe if you don't want to be delayed, you should be thinking about flying earlier in the day. Instantaneous. Less than 30 millisecond response on this. The same in Chrome, Safari, Firefox. So how do they do that? And that scales up to potentially millions of records, as long as you don't blow out your browser's memory limit. If I can find my mouse, this is a proprioception problem. I don't know where my mouse is. Somebody should do something about that. So that kind of gives you the idea of what I'm talking about, right? This instantaneous interaction, really fast filtering. Crossfilter also allows you the ability to, like if you wanted to add a different dimension for analysis, adding a new dimension and building up the dimensionality and groupings associated with that. So what I just showed you there was the elastic list example, Palladio, the dc.js example, and the Crossfilter website, which you can just Google for if you want to check out how that works. Now, key to this approach, and again, Crossfilter is a general purpose library, so we need to be able to handle any kind of dimensional data. And that doesn't necessarily mean flat data. It just means data that we can describe in a dimensional way. So we have to be able to pick out particular data points from our objects. We want to be able to have many different simultaneous filters. And we want to be able to maintain the interaction of those filters so that we know what data is within our filters at any given time. We want to be able to support any type of aggregation. So what I just showed you is primarily counts, some summations. But Crossfilter supports pretty much any type of aggregation that you are willing to program in a particular way. And again, we have to have interactive speed. And of course, we want to be browser native. That's the hard part, right? For this type of stuff before, a couple of years ago, usually you had to go to a backend server, do a query, wait for it to come back. You're talking at least a second, usually several seconds of wait time, which is not acceptable for a tool that is really going to enable people to be powerful in their ability to explore data. So now, actually, things are a lot better than they were a few years ago. We have a few options. The ones that I'm aware of are Crossfilter. Vega Dataflow is really new and really interesting, actually. It's based on a functional reactive programming paradigm. It has a little bit more flexibility than Crossfilter does. Porover is an interesting library that was developed by the New York Times about a year ago. It's not really active, but it's good for what it does. And then we can use our standard JavaScript libraries or even array methods or ES6 methods to do aggregations and filtering. Now, each of these has different trade-offs. Vega is really interesting. It's a fairly intuitive API. It's not super fast right now. I'm hoping that that can change. We're talking, it can handle on the order of about 1,000 to 5,000 records. 5,000 starts to get a little bit laggy with Vega Dataflow. Pour over, pretty performant, handles 10,000, 20,000 records pretty well. It doesn't handle aggregations at all. It's really made for just displaying tabular data and allowing you to filter down on it. So kind of like that first Moritz Stefaner Elastic List example I showed you. It was developed for news stories and for displaying data in that context. Crossfilter does support flexible data, filters, aggregations, lots of data, hundreds of thousands of records easily, as long as you're careful about how you program your aggregations and you use your memory. I've seen examples of Crossfilter being interactive at over 1 million records in the browser. As far as project activity and maturity, it's highly used, but the maintainers at Square are of the opinion, I think a reasonable opinion, that it's a complete library, that it doesn't really need any updates. It doesn't need further functionality. They do roll in bug fixes. The first bug in a year was found 2 days ago, actually, and it was immediately merged and a new release was cut. So they are maintaining it, certainly. Some people in the community think that there are some features that could be added, some improvements that could be made. So there is a community fork, a very young one, of Crossfilter that you might want to keep your eye on, that I'm involved in. We'll see where it goes, if it goes anywhere. So there are some options now, but we're talking about Crossfilter. So let me get into a little bit about how Crossfilter works to kind of introduce you. How many of you are very familiar with Crossfilter, have used it? Very few. All right, this is going to be good then, because I start with a pretty basic overview. We'll see how far we get. So to overview Crossfilter, how does it look in the browser? So when you load data into a web browser, whether you're using D3's CSV load method or JSON load method or just an AJAX call, you usually end up with an array of objects, right? And those objects will have properties, and the properties are basically what you want to do your reporting on. In this case, let's say we have an array of some sort of transaction, maybe, that has a particular value. And we're really interested in the color of the product we were selling. So we record that, and we record the date that the sale happened. We've got hundreds of those, thousands of those, whatever. To get started with Crossfilter, you just call the Crossfilter global object. If you brought it in with Bower, or if you brought it in with NPM, then whatever you called it. And you pass it your data, your array of objects. That's it. Then you've got a Crossfilter object, transactions in this case. You can't do anything with that. So, but we've encapsulated our data. It's in the Crossfilter. We can throw that array away and forget about it. Now, it's not really encapsulated. It doesn't copy those objects. So you don't want to change them after you've put them into the Crossfilter. So not only can you get rid of that array, throw it away, you really should. Just toss it. Now, we've got our data in our Crossfilter. We want to define dimensions on our data, interesting aspects of our data that we might want to report on, might want to present to the user in some way. And that means that we use the Crossfilter dimension function, or method, rather. And this method creates a dimension using an accessor that we pass to it. So in this case, we're creating a date dimension on the date property of that array of objects that we sent in. So this will fairly obviously create a dimension that is the date string. Something important to mention here is that we're kind of casting that. And because we're in JavaScript, we need to remember to be aware of how this works. This is not really the right way to do this. If date here is undefined, what does that end up returning? It returns a string. And what is the string? I think the string will be the word undefined. For a long time, I thought it was the empty string. And then I was unpleasantly surprised when I tested it out in the console and it was not. But call me on that if I'm wrong. So test these accessor functions so that you are sure about what it's going to return. Usually what I will do now is I will say, if date is undefined, return blank, an empty string. If it's not undefined, return date. Once we've got a dimension, we can filter on that dimension. So this is our date dimension, and we call a filter on it. We filter our data down to just that one date, January 1st, 2014, by a string. You can use date objects also if you want to do that. We can filter by range. Crossfilter supports exact filters, and it supports range filters. It's all the same filter method. There are also methods that are specific to each of those. The API documentation goes through them. But this will filter our data down to all the dates between January 1st, 2013 and January 1st, 2014. The API documentation is clear, not inclusive of the right-hand side. Okay? Inclusive of the left side, not inclusive of the right-hand side. We can also use a filter function. Slightly less efficient, actually, but it allows us to filter in any way that we want. So this is equivalent to an exact filter to 2013 June 1st, but we could do more complicated things then. Yep.
Under the covers, how's that range just like a less than?
Sort of. So yeah, what Crossfilter does internally is it will create a sorted array of dimension using your dimension accessor. Yeah, and then it uses a bisect function that it has built into Crossfilter to find the range that you've defined. So yeah. And then it actually converts that to indexes and then goes into a filter array that it maintains using a byte array and flips bits to indicate which records are in and out of the filter. So it's pretty interesting internally. I'm not going to get into that much, but yeah. So one thing, though, to get into the reasoning, the exact filter and range filter are very efficient because they can use that bisect operation. The filter function will run through every record in the data set and pass it through your filter function. So it's not going to be nearly as efficient as the other two. Usually that doesn't make much of a difference, but something to keep in mind. And then lastly, if we want to get rid of the filters on our dimension, so we will only have one filter on our dimension at any given time. Each of these will wipe out the previous one that you put on. And if we want to get rid of all of them, we just use the filter all method to wipe out filters. So that's the basic dimension filter API. You can also get rid of dimensions by calling a dispose method if you're doing a dynamic application that adds and removes them. So now our Crossfilter knows what our dimension is, our date dimension. It knows what filters we've got on it. We want to build aggregations on it so that we can eventually report on something. So an aggregation is called a grouping in Crossfilter, and it's based on a dimension. This group method just creates a group on the date dimension. It's a group of dates. What that essentially does internally is it creates a map. The keys are the dates that the dimension accessor returns, and the values by default are counts. So how many of our records fall into each of the dates that our dimension accessor returns. We can also pass the group method an accessor of its own, which takes the value output by the dimension accessor, in this case a date string, and it can do something to it. In this case, it just takes the month. It gets rid of the day. And that will end up being the key of our map. So here, instead of counting the number of records in each day, we're counting the number of records in each month, because the key of our map will only be the year and the month. More or less clear? Another built-in kind of convenience method that Crossfilter has on the group, again, this is the group object here, is reduce sum. So instead of counting, we'll sum. But the question is, what do we sum over? And in this case, it's whatever this sum accessor returns, the value property on our object. So again, we have to be careful about this, because if this is undefined and we try to add undefined to our previous value, we could end up in trouble depending on what our value is. But generally speaking, reduced sum will just add up whatever property we tell it to. So we've defined our dimension, we've defined our group, our aggregation, but we don't have any data out of the cross filter. We've just told the cross filter, this is the structure of our data, this is the structure of our aggregations, this is the filter we want to put in place. Now we've got to ask it for answers back. So cross filter is a stateful library, a stateful setup. We create a cross filter, we set it up, we filter on it, and only then do we actually ask for answers. And if we ask for an answer, a query, and then we add a filter or remove a filter or change a filter, and then ask for our query again, the same query, we'll get a different answer. Okay? So the types of queries, generally speaking, you can query a group or you can query a dimension. Querying a group gives you the aggregated value back. So we can ask for the top month, and we'll get the count of transactions in that month. We could ask for the top date, and we'll get the top day. Two different groups on the same dimension with different keys. And again, they're sorted. I mean, by default, they're naturally ordered. They're naturally sorted in descending order, but you can change that as well. We can also query on dimensions. So if we query on date dimension for the top 10 dates, we will get the highest dates. Okay? So if we have dates up to 2015, we'll get dates in 2015. It's just sorted in string order, or in naturally ordered order for whatever the data type of that dimension is. And probably the most useful method if we're going to be doing a visualization and we want to show our user all the data is the all method on the group, which just returns the entire array of objects. So it's actually not a map, but it returns an array of key value objects that you can easily convert to a map. So each of these returns an array of key value objects here. And sorry, I didn't put the little example here. But the date dim, the dimension query operators, will return the actual data objects that we originally passed into our cross filter. So we can actually get back our data by doing a dimension query. OK, so some things to remember, some of which I already mentioned. But dimensions are naturally ordered. And because of the way that the filters operate, using this bisect method, if you have a dimension that is not naturally ordered because your accessor doesn't return the same data type all the time. So sometimes your accessor returns a string, sometimes it returns undefined. You're going to have a dimension that's not naturally ordered. And bisect doesn't work when you have an array of non-naturally ordered values. So your dimension has to be naturally ordered. You have to make sure that if you return a string, your accessor always returns a string. If you return a number, your accessor always returns a number. So you really have to be careful to deal with undefined, which is pretty common in data sets where a property just doesn't exist, for example. Now, filtering on dimension also does not apply to groups that are defined on that dimension. And I'm going to give an example of how that works later that I hope will clarify it. But most people who are starting with cross-filter find that very confusing. So I've defined a date dimension. I've put a filter onto the date dimension. And then I query a group, my date group, and ask for the count of days in a particular day that's outside of my filter. You might expect that you would get 0 for that query, but you won't. You'll get everything that is in your cross filter if that's the only filter you've supplied. And the reason for that is actually kind of simple if you think about the way that visualizations work. If you think back to that elastic list example, when I wanted to click on a country to filter down to the country, the distribution of the country dimension didn't change, right? I don't want the stuff that I'm clicking on to filter to change. when I was dragging across the cross filter example with the flights, and I wanted to filter down to just long delays, the distribution of delays didn't change. Everything else changed, right? So the dimension that you're filtering on, you don't want to change in your visualization. When somebody is filtering across a histogram, that histogram should not move. When somebody is clicking on a faceted list to try to select that facet, you don't want the facet to move, because where they just clicked will no longer be there, and that ends up being very confusing. So generally speaking, you don't want filters that are applied on dimensions to actually change groups on those dimensions. You want them to change groups on all the other dimensions. Now, of course, there are times when you will want those to apply, and in cross-filter what you do is you just create a second dimension that's the same as the first one, and then apply your filter on one, create groups on the other, if that's really what you want. I want to highlight again this group accessor method is really key. If you want to have a less granular grouping than your dimension is defined as, months versus days. And then the ordering method on groups is what defines the sort order of the group. So when I ask for the top group, it's based on this ordering method that I put in, which is very similar to a JavaScript sort method, okay? Basically the same API. Cross-filter also has a limit on the number of dimensions. 32 is the maximum number of dimensions you can define. There's a pull request that's open to get that changed, but it needs more testing. So we'll see when it gets merged. But if you really need more than 32 dimensions for some reason, there is a branch out there that is that will support that. But if you want to test it, go for it. We're looking for help there. Really, 32 dimensions should be enough for anybody, right? Maybe at least until we get a little more memory in our browsers. So I talked a little bit before about cross-filter as being stateful. And when we apply filters in one dimension, and it changes all the other dimensions, cross-filter manages that all internally, but we have to be on the lookout for that, because if we're not paying attention to when filters get applied, when we call our queries, when we update our visualizations, we can end up getting into trouble. But why is it stateful, is the question. And the answer is so that we can provide this type of interaction that I just demonstrated earlier that's less than 50, less than 100 millisecond feedback times for quite large data sets that we normally wouldn't think that would be possible for in the browser. So let me walk through what the processing model of cross-filter looks like. Using a very realistic example, we've got our shapes. This is actually valid ES6, I think, right? Hopefully. I don't know. So we're building a cross-filter. We're doing it based on these shapes. These shapes have properties, right? We've got a triangle. It's blue. We've got green squares, right? Blue squares. If we want to think in terms of JavaScript objects, then this might be what it looks like. So when we create our cross-filter, we get a data variable out. That's what I'm calling it, data. And then we create a dimension, which we've talked about already. In this case, it's a color dimension, so it's a string, which is the color, blue, green, or red. And then we'll create a group, just like we talked about earlier. And that group will be grouped based on the color. So the number of red objects, the number of green objects, and the number of blue objects. Fair enough. If we want to add more data to our cross-filter, the cross-filter object itself has a method called add, which will take another array of objects, and it will be added in. And our groups synchronously with this add operation. So before this add operation returns, this is not asynchronous JavaScript. This was created before promises were a thing in ES6. Before this add operation returns, our group counts will update. So what happened there is each one of these new objects that were added was passed through the dimension. The dimension accessor returned a value, in this case the color. That color value for each of those objects was passed to the group, and the group counted it. It said, I got a red object, another red object, a blue object, and a green object. And it updated the counts on each of those groups that it managed internally. If we add another dimension, it's going to do the same thing. We add this dimension, and we add this group, and it takes every object that we've got here, and it passes it through the dimension and through the group, and it counts them up. So then we've got our shapes. So what happens if we filter? What I talked about earlier, just to illustrate it a little bit. We filter on our shape dimension. We filter to triangle, a single value. And it will get rid of all the non-triangles, right? The only things in our cross filter now will be triangles. Yes, triangles. And the group on the shape dimension doesn't change. The values don't change, right? They're still counting everything. The filter doesn't apply to this one. But the groups in the color dimension do change, right? And in fact, what happens is each of the objects that drops out of the current filter is, again, passed to the dimension and passed to the group, but it's passed to a different group aggregation function. It's not passed to the add function. It's passed to the remove function. And the remove function for a count group is just subtract 1 from that group, right? So that's exactly what it does. Now, when you have a lot of data and your filter changes a little bit, to just encompass that square or remove that square, updating your aggregations this way is a lot faster than recalculating your aggregations from scratch, right? Because you just have to, if you remove one square, you just have to subtract 1 from that group. That's all you do, even if you have hundreds of thousands of records. So that's how CrossFilter manages to keep its response times down in that millisecond range. So when I drag, especially a slider or something like that, across a histogram, each pixel that I drag that slider is just a couple of records. So CrossFilter can actually keep up with my drag because of this type of architecture. So we can do all kinds of fancy stuff. We can add groups. In this case, a sum. We can remove all our filters by doing filter all, and then that triangle filter will go away, and all the objects that were filtered out will flow back through the groups and be added back into them. So it's stateful. It's quite fast. For very small incremental filter changes, it's extremely fast. For larger filter changes, you can kind of figure out what the type of computational complexity is going to be if you know what your aggregation methods look like. So let's talk a little bit about aggregation methods. I talked about different functions for adding and removing objects from groups. And in fact, we have this reduce sum convenience method on the group object that I talked about earlier. But there's also a method called reduce, which lets you define your own custom reduce functions, more or less. And it's not just a reduce function. It's kind of a reduce and a backwards reduce function, right? So you've got an add function, which is your usual reduce function if you're doing like JavaScript array.reduce. And you've got your initial value, which is pretty similar to the array.reduce concept. For a count, for example, your initial value will be 0. But you also have this remove function. So for counts, for sums, for that kind of stuff where operations are just reversible, it's pretty simple. But the question is, what happens when you do something more complicated? And I'll show you a couple examples of that. The other method that I'm not going to talk about much, but which is fairly important in some use cases, is this group all method. It's one of the least well-documented methods in CrossFilter. When I talked about groups earlier, it was clear, I think, that every record goes into one group, right? Your dimension accessor function returns a value. That value is just the key for a group, and objects get counted or summed into that group. So every object can go into one group. A triangle goes into the triangle group. A red square goes into the red group. What if we have something like a tagging system, where an object has more than one value, and it might fall into more than one group? What if well, I don't know. Bad example, perhaps. But what if a square falls into the red group and the green group? Maybe it's brown. I don't know. What do? Well, we have to use the group all method, the group all kind of aggregation, which is like a group, but not quite like a group. Instead of having an array of objects with keys, and each object will belong to one of those, we're completely in charge. So by default, if we do date dimension group all, it'll just count up everything in the date dimension, and it will tell us how many records we have. But if we do group all and we define our own, we do group all.reduce, and we define our own add, remove, and initial values, we can make that initial value like a d3.map or something like that. And we can make our add say, all right, so if it's a red square, or if it's a green, well, if it's a red square, or if it's a brown square rather, it goes into both the green key and the red key in our map. So we can add it to both of them. It's up to us. It's completely our problem. When we take that group all object and we call the all method on it, or the value method on it, it'll just give us back whatever object we've got. It's kind of a complete free-for-all in that scenario. You can rebuild the standard cross-filter functionality using group all, which is kind of pointless. Or you can do something like putting a record into multiple groups, which is the primary use case. Bigger data is also a problem with cross-filter. If your data doesn't fit into your browser's memory, you're out of luck. You can't cross-filter it, right? So once you get over a few hundred megabytes of data, not only do you not want to load all that data to the browser, but you just can't. Last I checked, I think Chrome was limited to about 1 gigabyte of memory, but you probably don't want to push that much. So there are a couple ways to handle that. I'm not going to talk too much about that. There are some links on the website for the talk that go into that a little bit more. The basic idea is pre-aggregate on the server, and perhaps dynamically pre-aggregate on the server depending on what dimensions the user selected to view, and go from there. So let's talk briefly about the custom reducers that I talked about before. This is an example. These are all the same. So if you do a date dimension and you do a group, that's the same as doing date dimension group and then the reduce count convenience method. And it's also the same as doing the date dimension group and then the reduce method and passing it an add function. Well, it's best to start down with the initial function, which just returns 0. So that sets up your group. If you're counting, you want to start at 0. Your add function just adds 1. So P is kind of the way that cross-filter internally just refers to the initial value that comes into your reduce function. And V is the actual record, the actual the actual data object from your original data. So you can pull a property off that if you want to. It's actually not what's returned by the dimension. It's the actual data. But in this case, we don't care what V is. We just add 1 because we're counting. And if we remove a record, we subtract 1, again, because we're counting. If we're going to sum, then we've seen this before, the reduce sum convenience method with the value accessor. Or we can do it ourselves, and we can grab v.value and add it to our initial value. So that's counting and summing. What about something a little more complicated, like the minimum? What's hard about doing a minimum in this scenario? Yeah, you have to remember everything you've seen before. Because if you're just adding records, like writing a minimum reduce function on array.reduce is pretty easy. You just remember the smallest value you've seen. And if you see a smaller one, that's your minimum, right? But if I can then put a filter on my data, and I'm not going to want to recalculate the whole thing, how do I know what my minimum now is if I lose my lowest value? Well, I have to find the next lowest value. But to find the next lowest value, I have to know everything I've seen before. So to calculate a minimum, you have to keep a list of every single value you've seen previously. Not only do you have to keep a list, you have to keep a list of and remember how many of them you've seen previously. So that when a record gets removed, you know whether that value is gone or there are just one fewer of those values, right? So this is what a minimum function looks like in cross-filter, which is a mess, right? You don't want to deal with that. Basically, when a value gets added, we add it to the value list. If the value list object already exists for that value, we increment a counter. And if it's the smallest value, we just make it the minimum. When an object gets removed from our data set, either through a filter or through removing it from the cross filter, we find that value in the value list. If the counter is greater than 1, we decrement it. If the counter is 1, we remove it from the value list. And if it changes our minimum value, we just check and see what the minimum value in the value list is. This is maintained as a sorted list, and we use the crossfilter.bisect method to do that efficiently. So you don't want to be writing that all the time. It's really easy to make a mistake, to have a bug. There are a lot of other more complex, potentially, aggregations that you can do. There are helper libraries. One of them I maintain called Reductio. But you can basically encapsulate that logic. So if you're going to be writing those kinds of reducer functions, I would say either use a helper library or encapsulate it and then reuse your encapsulated logic. But this is what a minimum function looks like if you're using Reductio. You instantiate Reductio, you call the min method with an accessor, and then this returns a function that will actually just call the reduce method on a cross-filter group and use the correct functions as the add, remove, and initial functions. So it makes things a little bit easier. So I would say if you want to start using cross-filter, do counts and sums. Yeah, that's built in. That's easy. If you want to get into the more complicated stuff, if you want to learn it, great, do that. If you don't, then I would use a helper library to help you out. So I'll close up just briefly. But I wanted to get back to this idea of tool design. And this seems perhaps like a little bit complicated, perhaps a lot to go through just to build a basic data visualization. And I think that's true. If you're just going to visualize some data, just present some data to a user, then you don't want to be using cross-filter, like I said at the beginning. But if you're building a tool that is really meant to help people understand data and interact with it, then I think you need to be thinking about using something like cross-filter, whether it's cross-filter or pour-over or something I haven't heard of or something you've built on your own. I think it's really critical to get user interaction for data exploration activities down below about 1/10 of a second for pretty much all interactions that are exploratory. Setup is fine. I don't think that's bad. I don't think it's really even a problem. If you have to load data to the browser, if you have to spend some time pre-calculating, I don't think people mind that, at least in my experience. And I've worked with a lot of people on a lot of data visualizations, oftentimes in enterprise settings with really slow tools. People don't mind waiting for a tool to load up. I don't think that's the issue. What people mind is when they see the data and they have a question and they can't get an answer right away. It's that interaction that we have to work on making really fast. And so I think that the idea is try to make that as quick as possible, even if we have to go through some contortions on the developer side, using some things like cross-filter that may not have the nicest APIs, to try to make the tool that we're building for our user a really good tool, to make it what might be called ready to hand versus present at hand, where I'm not asking it for an answer and waiting for it to come back to me. It's a tool I can use on my data to really understand it. So a lot of things are important for that. Look and feel is important. User experience is important. It's got to be pleasant. It's got to be interesting. But I think this goal of essentially imperceptible response times for those types of activities is also a key aspect of those types of tools. So I'll leave it at that. You can get at the presentation and all the links associated with it at this address, and I'll send a pull request to Bobby for the GitHub repository as well. I'm on Twitter at ESJewett. And if there are any questions, I'm happy to take them now. Thanks. Yeah. not built into CrossFilter, no. Some of the helper libraries, I mean, Reductio does this, where you can either give it an accessor function, or you can just give it a string, which is the property name. So that works fine. I think the whole like anonymous function syntax is going to get a lot nicer pretty soon, so it'll be less of a problem. But yeah, the string approach is definitely an important one. Now, I've seen other libraries, not CrossFilter, but maybe like a React-based libraries that talk about that. Well, basically have a more in-depth syntax for accessing deeply nested objects and that kind of thing. I haven't seen that in the CrossFilter context. You'd have to use an accessor function there, basically. But it's a good idea. I mean, it would be nice for sure. Well, the CrossFilter philosophy was kind of interesting. I'm not sure I entirely agree with it, but I see the point. They wanted to make a library that just did the bare minimum, and they just didn't want to add things like that to the library. So I see the reason. Yeah. Any other? Yep.
How would you accomplish like the union of line?
Yeah. The question was how to accomplish like unions or intersections of different filters, that kind of thing. So right now, CrossFilter does not support that in any sense. Porover actually does support different types of combinations of filters. There is some discussion about adding the concept of filter groups to CrossFilter, which would involve a little bit of a change, or probably a non-breaking change to the API, where when you did a query, you would specify which filter group you wanted to query against, and then you could build new filter groups based on unions or intersections of existing filter groups. But no, nothing like that right now. Basically, the way that you do that now is you create a second cross filter, and it's up to you to merge the results, which is not pretty, and usually often not possible to do what you want to do. So, other questions? All right. Enjoy the rest of the conference.